Welcome back to Arxflix. Today, we're exploring a fascinating paper titled Adding Conditional Control to Text-to Diffusion Models, which introduces ControlNet. This architecture enhances large, pre-trained text-to diffusion models like Stable Diffusion by adding spatial conditioning controls. Here's a snapshot of how ControlNet works, locking pre-trained models and reusing their robust encoding layers. Let's dive deeper into what this means and why it matters. While text-to-image diffusion models can create stunning visuals from text prompts, they often lack precision in spatial control. Imagine wanting to create a detailed scene with specific poses or shapes. Text prompts alone can make this a cumbersome trial-and-error process. That's where ControlNet comes in. ControlNet integrates additional input conditions like edges, depth maps, or human poses into the large pre-trained diffusion models. This approach ensures we can finely control the spatial composition of generated images. The key is the zero convolutions that connect this new architecture without introducing harmful noise during training. Here's an example showcasing ControlNet's capability to process various input conditions without text prompts. The results are robust and semantically rich. ControlNet starts by locking and copying the pre-trained model's parameters. It introduces additional zero convolution layers, which have weights initialized to 0. This ensures the copied model gradually learns the conditional controls without affecting the performance of the original pre-trained model. This equation describes how a neural block transforms an input feature map BMX into an output feature map MI. When ControlNet steps in, this equation evolves into one incorporating zero convolutions and conditioning vectors, allowing granular control over image generation. Initially, I text equals MI, ensuring no harmful noise. ControlNet can be seamlessly integrated with Stable Diffusion, which has 25 blocks and leverages latent images, reducing computation cost. This integration adds trainable copies of the 12 encoding blocks and one middle block, connected through zero convolutions. This figure shows Stable Diffusion's an architecture augmented with ControlNet. The locked blocks are in gray, while the trainable blue blocks and white zero convolution layers make up ControlNet. Training ControlNet is efficient and scalable, achieving high-quality results in less than 10 optimization steps due to the sudden convergence phenomenon. Extensive testing across various datasets and conditions, such as depth maps and human poses, shows robust performance and semantic understanding. As seen in this figure, ControlNet can abruptly succeed in following input conditions, a phenomenon termed sudden convergence. Another remarkable feature is the ability to compose multiple conditions. By adding outputs of corresponding ControlNets, we can handle complex scenarios, like combining depth and pose for a single image generation. Here's an example of using both depth and pose conditions simultaneously, showcasing ControlNet's flexibility. User studies and comparisons to other methods like PI-TI and sketch-guided diffusion prove ControlNet at superior performance in both result quality and condition fidelity. This figure highlights the effect of classifier-free guidance and the proposed CFG resolution weighting on the quality of generated images. ControlNet is scalable with different training dataset sizes and is capable of interpreting ambiguous input conditions. Furthermore, it can be transferred to other community models without retraining, proving its versatility. ControlNet can transfer smoothly to various community models, as shown in this figure. In summary, ControlNet is a powerful, adaptable neural architecture that introduces spatial conditional controls to large, pre-trained text-to diffusion models. It retains the original model's robustness while allowing for precise, condition-based image generation. Thanks for tuning in to Arxflix. Be sure to subscribe for more deep dives into cutting-edge research. Until next time, keep exploring the fascinating world of AI and machine learning. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.